Hello guys, welcome to this one short video of Linux for DevOps. This is a complete zero to hero video consisting of basics to the advanced, and I made sure to make these topics simple and understandable. I strongly think this would be one of shortest one shot video for Linux for DevOps, and I have concentrated each concept so you only know what is required, and it is no BS or one shot video. And apart from all these commands and concepts, I've also included one project hands-on with the AWS concept and Linux commands and file management. So all these concepts and a project is covered in this entire one shot video of approx 2 hours. This video took me around 1 month. Would appreciate if you watch it completely and let me know your thoughts. So without wasting any time, let's begin. The topic is what is an operating system, its key functions, big three operating systems, that is Linux, Windows and Mac OS, what is CLI command line interface, and what is GUI, why we prefer Linux over Windows. An operating system OS is a core system software that manages a computer's hardware and software resources, acting as an intermediary between the user and the machine to provide common services and an environment for other programs to run. It handles essential tasks like memory allocation, process scheduling, CPU time, input or output control, keyboard or screen printers, and file management, making complex hardware interactions user-friendly. Without an operating system OS, users would need to directly program hardware, making devices impractical. An operating system OS is the most important software on our computer. We can think of it as a manager of the house. It makes sure electricity goes in the right rooms and furniture or that is a hardware is organized, and people, which is like an apps, Spotify or Chrome, can do their jobs without bumping into each other. So operating system acts as a mediator between the hardware and the user. We cannot directly communicate with the hardware. We need something to communicate. So that something is called the operating system software. So we use operating system, and it provides a software, UI, GUI and CLI, so we can communicate by commands or by interface with the hardware for doing tasks like memory allocation, process scheduling, etc. So what are the key functions of an operating system or OS? First is resource management. It allocates CPU time, memory, storage and peripherals among applications. User interface, UI, provides users ways to interact, that is GUI or graphical user interface or command line interface, CLI. File management. It organizes and manages files, directories on storage devices. Process management. Controls the execution, scheduling and termination of program or processes. Device management. It communicates and manages hardware devices via device drivers. Security. It offers basic security features like user authentication and firewalls. In short, it makes the hardware useful. Hardware in the sense we use computers as an hardware, so the computer has various features that it offers. In order for us to use those features, we would need something to communicate. That something is called a software or an operating system. It helps us use resources, use UI or GUI or CLI, and it helps us get access to file management, process management, device management and security. So what are the big three operating systems? That is Windows, Mac OS or Apple, Linux. One of the most popular operating system in the world is Windows, which is great for GUI or graphical user interface, gaming, and most compatible software for offices. macOS Apple, it is known for its sleek, stable, just working. It is exclusive to Apple computers, MacBook or iMacs, and is favorite for designers and video editors. It is also a GUI. And Linux, It is an open source operating system, meaning it is built by community. It comes in many versions called distros like Ubuntu, Mint, CentOS, etc. It is the engine behind most of the world's internet servers. So Windows and macOS operate on graphical user interface. We have to operate it by mouse, keyboards, and use it is like UI. You can see the features you have to cancel and everything in the screen. Whereas in Linux, we use it works on CLI or command line interface. We put the commands to communicate with the hardware for the resource management and etc. features. So what is the difference between CLI versus GUI? Feature, how it looks. GUI has icons, buttons, windows and menus to communicate with the user and the hardware, whereas CLI or command line interface is a black screen with plain text. Plain text in the sense that are the commands we put. How we use it? By pointing and clicking with a mouse in GUI. In CLI, it is by typing commands or text. GUI is best for everyday users, and CLI is best for developers and experts, DevOps engineers that work relentlessly on the system and the hardware and the back. An analogy: GUI is like picking a food from the picture menu, and CLI is like writing a letter to the chef to fulfill our needs. Why many prefer Linux over Windows? And in short, we can say why many developers or backend engineers or infrastructure DevOps engineer prefer Linux over Windows. While Windows is like a standard for many, people switch Linux for these simple reasons. That is, it is free. Windows costs money, often hidden in the price of a laptop. Most Linux versions are 100% free and free to download and use. Privacy and security. Windows often collects data on your usage. Linux is more private, much less likely to get hit by Windows viruses. Speed on old computers. Windows can get slow over time. Linux is lightweight and can make a 10-year-old laptop or junk laptop fast again. Total control. In Windows, you can only change what Microsoft allows. In Linux, you can change everything from how it looks to how the control system, how the core system works. So we have more control in Linux, and in Windows, we have only the control that the Microsoft allows us to control. Better for coding. Most programming tools are built to work perfectly on Linux right off the box. So as we can say, like Linux offers, it's free. Linux is free. It has more privacy. It's an open source, so it offers speed. It is lightweight. It offers more control than Windows, and it is better for coding. So we prefer, or many prefer, or many infrastructure DevOps engineers prefer Linux over Windows. So the summary would be Windows, it is best for Windows like gamers and businesses, UI or GUI. It is the standard for offices. Mac OS is for creative Apple fans or UI and video editing. It is like polished and simple. Linux is for techies and privacy seekers, and CLI, which is for freedom and customization. The topic is components of Linux machine, its architecture and its layers. Also, what are Linux distros or Linux distributions or flavors? Architecture or components of Linux machine includes the core, that is the hardware, then kernel, then shell, then applications or utilities. So you can think of it as Linux machine is like a restaurant. The hardware is the building and the kitchen, while the operating system is the staff and the menu that make everything work together. That is the four main layers of Linux machine. The Linux architecture is designed like a series of protective rings. Each ring relies on the one inside it to work. So the first component would be the hardware, the core. This is the physical body of your computer. What it is: the CPU, brain, RAM, memory, hard drive, storage, and the motherboard. So the hardware simply is the hardware, physical device or your laptop or a device or a computer. Something that is physical called the hardware or the motherboard, CPU. All this comes under the hardware layer in a Linux machine, and the second would be the kernel or the brain. So we must know this fact that you, as a human or any person, could not communicate with the hardware itself. In order for the hardware to understand your language or the communication, or there is something known as the kernel. Kernel is like the brain that lets the hardware understand the commands or the instructions which we are giving. Linux commands or distributions through the brain. That brain is the kernel. Kernel helps hardware communicate with humans or humans to communicate with the hardware. So what it is, the kernel is the most important part of the operating system. It lives right above the hardware. It is a specialized piece of software that talks directly to the hardware. It manages memory and tells the CPU which tasks to work on next. It is like the head chef. You don't talk to the chef directly, but they control everything in the kitchen, make sure the equipment is being used correctly. So the third would be the shell, the translator. The shell is the layer that wraps around the kernel to make it usable for humans. It is an interface that takes your commands like open this file and translates them into language kernel can understand. So in simplified, it is like a waiter you give the order to. So the shell is like the interface through which you can communicate through the kernel. You directly cannot communicate to the kernel. The shell would be like the translator that helps you communicate with the kernel so that the kernel will communicate to the hardware to fulfill your commands or instructions. And fourth would be application and utilities. That is like the tools. This is the outer layer, the part you actually interact with every day. Utility is simple, specialized tools for basic tasks like listing files, ls, copying data, etc. Applications, complex program for end users like web browser, etc. So application and utilities is simply the commands or instructions you provide for getting the needs like applications, utilities, or commands like ls, copying data, cp. So that commands you communicate is known as applications. Need or your instructions that are fulfilled is in the layer application layer. That the commands you put is communicated to the translator, that is shell, and that shell communicates to the kernel. Kernel communicates to the hardware. First would be application, where users gives commands that the kernel understands. In order for the kernel to understand the commands, it needs translator, that is shell. Shell is like the interface that is between your application commands and the kernel. So after you give commands, the shell understands it and the kernel also understands it. Then that kernel communicates that commands or your instructions that it understood through the hardware. So your instructions are fulfilled in these four layers. Component, that is like the hardware, it executes physical tasks like kitchen equipment. Kernel, it manages resources and hardware, it is like the head chef. Shell, it translates user input for kernel, it is like the waiter. Apps or utilities perform specific user tasks, the finished meal. So now what is a Linux distro? Because Linux is like the open source, free for anyone to change. Different groups of people take the Linux kernel and bundle it with different shells and desktop environments to create a finished package. These packages are called distributions or distros. You can think of it like Linux, like it's like the ice cream, and the kernel is the base, milk and sugar, but a distribution is the final flavor like the chocolate, vanilla, or rocky road. They all use the same base, but they look and taste different. So Linux distribution you can understand by knowing that Linux is open source, so the distributions you see like Ubuntu and everything has a core architecture or core components or core libraries that is Linux. And to make it more efficient, to add more commands and more instructions for users, other companies or other organizations have used that open source Linux to create their own versions or flavors or distributions, so users can choose between which they want to prefer. So popular distributions or distros in 2026. It is like the Ubuntu, it is for beginners, it is a standard, it works for most of the users, and it is efficient. Linux Mint, it is for Windows features, looks fresh. Fedora for developers, Arch Linux for experts, Zorin OS for modern users. It is extremely beautiful and easy to use. So these are some of the Linux distributions. There are many, that is like Kali Linux for cybersecurity, and some more as well. Also remember, like after today's lecture, you would need to be prepared with your Ubuntu or your WSL to practice the commands, which would be a practical sessions. So I would you can search it up, how to set up your WSL or Ubuntu, or how to get Linux in your Windows or in your Mac OS. You wouldn't need to do the instance thing for this. You can search up on YouTube. Many videos are available that would help you guide to download or how to use the Ubuntu or Linux in your Windows. So yeah, I hope you would be prepared with those prerequisites for the upcoming lectures. Today's topic is practical session on Linux basics, which would be Linux apt or package manager, directories, users, root users. As you can see, I am in my Ubuntu terminal. You can see it is root at desktop pqter, which is my desktop name, followed by colon tilde hashtag. So here root stands for root user, which is like the administrator. By default, when you are using a terminal, you log in as an admin user or administrator. At and followed by desktop is my desktop name. In this case, it can be instance. If you are in an instance, it could mean host name. Root user has all the permissions, all the privileges which other users doesn't have. In an organization, there is a admin user, that is a root user that has all the privileges, and they allow or they create certain users by your name. If it is KEF, it would create KEF, and it would have some limited or allowed privileges or access. In an instance, if you create it on AWS or Azure or other cloud platforms, by default you log in as an Ubuntu user. It doesn't by default allow you the root user access. You would need su command to get into the root user. And after desktop pqter, you can see it is colon tilde hashtag. Here tilde represents /home/root. That means home directory of the user. In this case, the user is a root user, so it would be /home/root. Root is the user. So yeah, tilde equals /home/user. If it is on instance, it would mean /home/ubuntu. Ubuntu is the user. So now what is apt? apt represents package manager. Package means packages that are required. Packages are the packages that are required to fulfill the task or fulfill our requirements for using a Linux as a machine. For example, packages can be Python packages or many other packages that we use for like web development or other purposes in DevOps as well. So the packages are located in the, if we are using Ubuntu, it is located in the Ubuntu archive, in the archive of the Ubuntu server. So it fetches those packages from that into your instance, into your terminal, into your device. So apt is equals to package manager. As you can see, if I put apt, it shows like it has certain apt commands, apt list, apt search. So we must be updating apt so it can update the packages. So if I click apt update, it updates the packages in my terminal on my Ubuntu server or in my device. What does apt install do? Apt install installs the packages that you want to install. For example, if I do apt install Python 3, it installs Python 3 into my device or into my folder or into my directory or into my machine. and slash equals to path. Path equals to present working directory. Slash followed by something equals present working directory. If it is not mentioned anything after it, it is the root directory. Sometimes it is mentioned root, sometimes it has mentioned hashtag, which means it is a root directory. Now let's do ls command. Now you can see the packages or the libraries that are by default installed in the Ubuntu. If we do ls-ltr, we can see some more details of these libraries or packages that are by default present in our Ubuntu. Now, if we perform su and if you have created the username, in my case, I have created a username or a user that is kf, and if I perform su kf, it would direct me towards the user. It would direct me towards the user. So I will do su kf, and you can see I'm now present in the user that is kf, not in the root. As I mentioned initially, root has all the privileges, and in organizations you don't work on root, you would get access or you would be created into a user by your name, and that would have access of what is allowed for you to do. So in my case, I am in the user that is kf. Su kf directed me towards the user that is kf. So now it shows, now it doesn't show root, it shows kf at desktop followed by the previous thing. So yeah, it means that I am now on the kf user. The topic is binaries or libraries in a Linux machine. We will be discussing key binaries and libraries in a Linux machine that are sbin, library, lib, boot, bin. Libraries or binaries in a Linux machine simply means that these are like some commands or some functions that help a user like you and me to communicate to the hardware, to the Linux machine. So these binaries and libraries helps users communicate with the Linux machine. LSLTR, it shows you the libraries and binaries in a Linux machine that are like sbin, lib, boot, bin. Let's do ls sbin to list the system binaries. Sbin stands for system libraries. System libraries are used to manage system as an administrator, and it helps removing, adding users, groups, etc. And you can see in this system binaries there is commands that is used by administrators. So normal users doesn't have access to this system binaries. It is to prevent from hack or corruption. So only administrators or trusted users can have the access of these binaries. So in this sbin, we can see there are commands like group add, group delete, add user, etc. So these are commands that are most probably used by administrators, so they can add or remove groups and do the administrative task. So next, when we do ls lib, that is libraries, these are system libraries or libraries in a Linux machine. These libraries are used by Linux kernel, and these libraries in a Linux machine, these libraries helps us communicate with the hardware. So when we imagine kernel performing tasks or kernel communicating with the hardware, it is with these libraries it communicates with the hardware. So as you can see, these libraries has like WSL, Python 3, etc. So these are the libraries that helps the kernel communicate with the hardware. So now boot. Boot is not a file that we can see simply in our Linux in our desktop. But however, if we see in the instance or if we observe in an instance boot folder, we can see some files in it. So boot simply means the restart and start of the Linux machine. So now let's understand what is bin. Let's do lsbin. So we understood that sbin stands for system binaries. Now user binaries. This can be used by normal users other than administrative users. So it is not limited to admin. Any users and perform the commands. In this ls bin, these have many commands like tail, top, apt, etc. These are the simple commands or commands that any users can perform. Now, when we observe the sbin in the lsltr, we can see that it redirects with usr/sbin. So usr is you can say root folder that has the files or the subfolder that is sbin, lib, libraries and binaries. So for that, it is a shortcut. For it, the shortcut is lib. So usr/lib, it also simply is lib. So also for the sbin as well, it is in the usr/sbin folder. Sbin is a shortcut for usr/sbin. Lib is a shortcut for like usr/lib, and bin is a shortcut for the folder usr/. The topic is directories in a Linux machine. We will be discussing what are srv, folder, opt, mnt, var, home, data, proc, dev, sys, tmp, root, test, run, etc. We will discuss the importance of these folders and how these folders operate in a Linux machine. This is the part 2 of our previous directories video. So we can see the folders in the root or the default libraries in a Linux machine. So let's first understand srv. After we do ls srv, we couldn't see anything as of now, because srv or server folder in a Linux directory stores configuration files related to the web server. So when a web server is created, srv by default stores the configuration files of that web server. So now, what is opt in a Linux directory? Opt in a Linux directory stores third-party dependencies. It requires admin access or admin's permission for users to store third-party dependencies. Third-party dependencies here means the dependencies that are other than the dependencies present in the Ubuntu archive or Linux archive. So Linux archive has dependencies by default. So if the third party, that is the dependencies we take from the internet, that dependencies are to be stored in the opt folder. Why? Because if we store that in the /home/ubuntu, so if suppose I'm using the directory /home/ubuntu, so that means I am the user that has that third party dependencies, and if it is stored in /home/ubuntu, if someone else has to access that third party dependency, they would need to access the user that I'm using, so they could access that third party dependencies from the home/ubuntu folder. And to have privacy and security and reliability, the best practice is to store third party dependencies in opt folder. That would act as a common location for other users to access it without needing to log in or using the other users account or other users for that third party dependencies. So now next is mnt. mnt in Linux directory stands for mount. The purpose of mount is to add disk or mount storage or volumes. Linux admins use mount to add storage or add volume or mount the storage. If suppose by default there is a storage of 10 GB and there is a requirement to add more storage, so the storage is added and managed using this mount folder. Simply it is used to manage storage or volumes. Next is var. Var is to store the log files. It stores third-party libraries or the libraries that you download from the internet. Now home. Home is a home directory that has users that you create. For example, if I do ls home, you can see the users that are Ubuntu and Kev. So if I do su kf, I can access or log into the kf user. Next is data. Data in a Linux directory means that any data that can be shared to another admin or Linux admin or any other person in an organization, that data can be stored in the data folder of a Linux directory. If you want certain data or the files to be sent to other or people in the organization, that can be stored in the data, so it can be accessed from that folder and easily sent to other members of the organization or other administrator or Linux administrators in the organization. Now proc. Proc is a virtual file system that provides a window into the kernel's data structure. It shows information about running processes and system status. Basically, it shows the running processes or system status. We know that kernel directly speaks with the hardware. So that kernel has a data structure. If something has a data structure, that would obviously be having some information or processes or system status that are like process IDs, CPU info, system info, or memory info. To monitor memory, CPU in a kernel, proc is used. Or proc is a folder that has information related to virtual file system of the Linux kernel. Now what is dev? Dev is a virtual directory containing device files. For example, /dev/sda for a hard drive or /dev/tty for terminals. Dev directory represents every piece of hardware that is connected to the device or the computer. Usually, a computer thinks of hardware like electronics, but Linux translates those electronics into files so that programs can talk to them easily. For example, if you move a mouse, Linux send those movements to a file in /dev for the computer to read. /dev/input, this folder contains files of mouse or keyboard. So in short, /dev directory is just like a folder full of shortcuts that can communicate to the hardware. So /sys in a Linux directory means that it is like a dashboard or settings menu of the Linux system to find information related to disk, battery percentage, CPU, etc. It allows users to access that system information as in a normal text file that is readable. So now what is TMP? TMP folder in a Linux directory is a standard directory for storing temporary files needed for short-term use by applications and users. These temporary storage can be deleted or are usually deleted on system reboot or by cleaning jobs. You can understand it by simply remembering in iPhone or iOS, if you delete a photo or any file, it is stored in a recently deleted folder. So there is a timeline until which it is permanently deleted. You can either restore or delete it permanently or wait until it gets deleted. So temporarily is similar to that. It has certain timeline until which the files in the TMP folder gets deleted. Now root. Root is a root directory that has administrative powers or administrative privileges and administrative permissions that are higher than the other users. Now test. Test in a Linux directory evaluates conditional expressions. Test command can be used for variety of comparison and checks. It finds attribute checks file exist in a regular file. Basically, it is used to compare or test conditional expressions. Now run. Run in a Linux directory stores runtime data of the processes. If a process is running, its runtime data is stored in this run folder. Now etc. etc is a very important folder in a Linux directory. It has system configuration files that is similar to the settings app in the Windows or settings app in our smartphones. That is like it shows you the Linux operating system information, basically information related to the system configuration. And you can simply remember it like the settings app in our smartphone or Windows or anything that is similar to settings. So it is like settings in a Linux machine. Now we understood these files or libraries or binaries in a Linux directory, but you would be wondering, when we do ls, it shows us these files or libraries in a Linux directory. So you would be thinking we are not actually entering the full path for the Linux machine to understand ls. Why is that? You can understand it by remembering that it is stored in the path. What is a path? Let's do echo. Echo $path shows us that $path is a path that stores the shortcuts of the commands. And if a command is stored in any one of these folders in the path, then it directly fetches that shortcut from those folders or paths located in the $path. So when we do ls, it is stored in one of those paths in these folders on these paths. So when we do ls, it Linux machine directly checks if it is present in those paths. If it is present, it understands it as a shortcut and executes our task or our command. The topic is user management in Linux. What is the importance of user management? Some commands, that is user add user, deleting the user, checking the user password, and some more commands. So why do we need user management in Linux? We know that root user has all the privileges and all permissions. It is like the admin, whereas other users other than root user doesn't have that much privilege or that much permissions to perform tasks. So if we consider that we don't need user management, and we also believe that all users, including users other than root, have all the permissions similar to the root, they can perform any task or all the permissions, in short. So the problem comes is when we would not be able to find the accountability on the actions of the users. If suppose user deletes the system binaries or some important binaries or libraries in a Linux machine, and you wouldn't be able to find which user has deleted that. To prevent such issues and such problems, only admin or selected users would be allowed to have such permissions, and users that are added will have selected permissions that are allowed by the admin or that are allowed by the organization. Let's first understand what is the importance of the command user add. User add is a command that is used to create the user. You must perform user add space the username you want to create. I'll name it Kaif Khan. And it's been created. We can check that by using vim space /etc /passwd, and also by doing cat followed by /etc /passwd. We can see that the user is created and it is visible in this passwd folder in the etc. etc is like the settings in the Linux. Without password, user is not of use. So to create the password, we would be performing the command, that is passwd followed by the username, that is Kaif Khan. Add the password, confirm it. Now to check that password which we have created, we need to perform this command, that is cat space /etc /shadow. As you can see below, Kaif Khan user has some encrypted password present. You might be wondering or thinking that you could be decrypting that password. It is not possible. And if we hypothetically imagine that you forgot the password and you want to get access to your account, and you can have access to this encrypted password, and you could be decrypting and get that original password because it is highly encrypted. And also there are some third party methods that say it is possible, but that is not safe, reliable and secure, and it is not acceptable in organizations to perform such. In short, it is not possible to get access to your account if you forgot the password. Now there is a command that is userdel that is used to delete the user. Let's delete it. Userdel space Kaif Khan. So that was about the command user add and user delete, checking the password, creating the password. But however, this user which we have created doesn't have the home directory. To create a user with the home directory, we must be using the other command that is add user. This command will allow the user that is added to have home directory as well. Let's do add user. We'll name it Kaif Khan. Add some details. Save that. Now that user is created, we can check that by getting into the root user and performing ls space slash home. So that shows that the counts or users that has the home directory. You can see Kaif Khan user is now having access to home directory, or it has home directory. Now to check the importance of user management, we know that root user has all the privileges and the user we create doesn't have all the access or permissions to perform certain tasks. Let's check it now. Let's perform rm space -rf slash sbin. Now you can see that we are not able to perform this task in the user Kaif Khan. It says permission denied because the user we create other than root or users other than root doesn't have all the privileges or permissions to perform such tasks. That is why user management is such an important task. Also, we might be wondering what is the difference between user add and add user, and why is add user even a thing when we can use user add. Add user command is very efficient. It can be used when we can automate the test. We can use that in the code automation and in the commands where we can just simply use add user followed by username. If we were able to use the other command that was user add, that prompts us with some more details to add, that is like the phone number, other details, full name, etc. So when we have entire code with this command add user, etc., so it makes the code and the running of the code runtime more efficient and more easy, and it doesn't break in between when the prompt comes. If we were to be using user add command, it would be prompting to provide full name, etc. So it would be halting the progress. To prevent that, add user is a simple command that runs easily and adds user efficiently. Now there are some more commands, that is ch space hyphen capital M space duration. I will do it 30 space username Kaif Khan. This command will make the password expire within 30 days. And the other command is passwd space -l space username Kaif Khan. This command is used to lock the user. If certain user is performing spamming task, we can lock that user by this command, and we can unlock this user by passwd space -u username Kaifkhan to unlock this user. The topic is user management in Linux. Today you are going to be learning what is the importance of user management in Linux environment. We know that users have certain significance, like root user has all the permissions and other users are having limited permissions, or the permissions that are allowed by root users or administrators, or permissions that are allowed by the organization. When a situation comes, there is a need to change permissions of n number of users. If that number of users are 10, 15, or at least 20 as well, Linux administrators or system administrators can change that, even though it feels tiring for 10, 20 users, but they can do it. But imagine if that many users are, if users are 100, 500 or 1000. So changing permissions for these many users is really like not impossible, but it is very tough and it is not easy job. So to help with that and to have more reliability and to save time and efforts of Linux administrators or system admins or for users, there is the need for user management. User management is used to group users based on their responsibilities or roles. If suppose in an organization there is 50 DevOps engineers, 100 software developers, and 200 network engineers. So these users are placed in the groups, and if the situation comes to change permissions of members in a group, so it would be really easy to change permissions in a group, and all the users in that group would have the permissions changed directly or indirectly. So the first command to create the group is group add space name what you want to give. I'll give it caffeine verse, which is my channel name, and enter. As you can see, the group has been created. To see the group, the command is cat space /etc/group. Enter. Now you can see that caffeine verse group has been created with the group ID as well. So now the group is created. Let's now add our user Kaif Khan into this caffeine verse group. So the command would be user mod space -a capital G space group name caffeine verse space username Kaif Khan. Click enter. Now that Kaif Khan user is added into the group caffeine verse. Also now changing permissions of the group caffeine verse would directly change the permissions of the member Kaif Khan. And if there is an opportunity to add more users in this group, those permissions would also be affected. So that was about adding the members and creating the group. Now let's understand the importance of SSH, that is Secure Shell. Secure Shell provides secure encrypted connections for remote management and data transfer. Secure Shell replaces insecure protocols like Telnet. It enables encrypted remote logins, command execution, file transfers. So the key important use of SSH is security, remote access, file transfer, authentication, tunneling, and port forwarding. Previously it was Telnet or FTP. Now it is SSH for the secure shell connection. Now how can we do SSH for our Linux environment? So let's understand this by this example, that is, in an organization, system administrators or Linux administrators will set up an instance. Instance is something like Elastic Compute Cloud, EC2 instance in AWS and in other cloud providers as well. So in this instance, they would create a virtual machine, or in the instance, they would be logging in into the root user, and they will create your username, they will create your password, and that instance also has the public IP address. So these details are sent to you, and you would be using Git Bash if you are on Windows, and you would be using terminal on macOS to log in into that Linux environment. So if you are in the Windows, you would be opening the Git Bash, and you would install the SSH client first. Then you would perform this command, that is SSH space your username that is created at public IP address of that instance. Then you click enter, then you enter the password. After that, you would be inside the Linux environment. Also, there is another method that is to log in with SSH using PEM file. Watch this video for the PEM file method. Let's create an EC2 instance. Click on launch an instance. I'll name it KF demo instance. Let's choose Ubuntu. I'm on the free tier. You can also try it on the T2 micro free tier. Just go below and I'll create a new key pair login. That would be .pem file for a secure shell or SSH login. It's downloaded. Create security group and change the VPC from the default to the VPC which we have created, that was KF demo VPC. So let's select that. Now we have attached the VPC to the EC2 instance. Usually what we do is we select the private subnet of your selected VPC. But for this demo, we would be selecting the public VPC subnet. Click on Auto Assign Public IP enabled. Now let's create an instance or launch an instance. It's launching and it's successfully created. Now copy the public IPv4 address so we can do the secure shell SSH. In Git Bash as a terminal, you can use others as well to connect to your instance through SSH. Now click enter, click yes, enter yes. Now it's connected to SSH or to your instance through your terminal. So the topic is file management in Linux. You will be learning commands used in file system and in directories. The first command is ls. ls is to list the files or directories present. And see, after doing ls, we were able to see directories and files. Now to change the directory, the command is cd space and the directory you want to switch. So I'm in the tmp directory. Now again we can do ls to see the contents in the tmp directory. Now to move back from the present directory, the command is cd space 2 dots. Now to check which directory you are present in, the command is pwd present working directory. This tells in which directory you are present. Now to create a directory, the command is mkdir, that is make directory, mkdir space the directory name. I'll name it Khan. ls to check it's been created. Now to remove or delete the directory, the command is rmdir space the directory name. Now it's deleted. There is another command to remove or delete the directory, that is rm space -rf space the directory name. Now it's deleted. That was about directories. Now about files. To create a file, the command is touch space file name. I'll do touch space Khan. Now the file has been created. To remove the file, the command is rm remove rm space file name. Now it's deleted. To copy contents from one file to the new file, the command is cp. It is cp space or existing file space the new file name. Now to rename the file, the command is mv space the file name you want to change space the new file name you want to name it. Now that was about the empty files. To add contents into the file or to add text inside the file, there is vim editor. By doing vim, you enter into the file from vim space file name. If you already have a file that you have created by touch, you can add that, or if not, you can also perform vim plus new file name. So you enter into the file. Now to add text, you want to click I. This would make your editor into the insert mode. To save and quit, the command is escape :wq enter. This will save the file and quit. Now to see contents inside the file, the command is cat space the file name. Now you can see the file contents. Now to save the file without any changes, the command is escape :q exclamation. So let's again enter the same file. Now you can see the text that I have added is not safe as we did not do w. W would save the text. I created another file with head prints the top of the lines inside the file. Head space hyphen the number of lines space file name. Enter. This would print top 25. Now for tail, it prints bottom lines of the file. Now echo is a command to also add the text. Echo text double arrow file name. This would add text in the last line of the existing file. Let's see that with the tail command. You can see the text is added. Now to replace existing text with the new text, the command would be echo space text space single arrow file name. This command would remove all the text and only add the new text. The topic is file permissions in Linux, importance of file permissions, and we will be doing some commands and file permissions to see how it works. So what does file permission mean? We know that in Linux there are users and groups, and also there is a Linux server. In an organization, every user works on a Linux server, and not all users have the same permissions to the files or the folders. For example, admin, root user has all the permissions and it assigns the permissions to the other users. For example, developers or DevOps engineers, there are developers in one group and DevOps engineers in one group, and network engineers in one group. All these groups will have different permissions. So why there is the need of having different permissions for different users or different groups? If suppose all users were having all the permissions like root, there would be a lot of chaos. If a user deletes the system binaries or important files, there would be system corruption. Giving access to all files or folders to all users increases the chance of its deletion, its corruption, and its manipulation. To avoid that confusion, only users that need the access of the files. For example, if developers need access to certain folders and certain permissions, they are granted that access. Whereas if DevOps engineer group doesn't need that access or doesn't require access of it, so they are denied it by in accordance to the roles and responsibilities of the users and what they perform, the permissions of the files or the folders are given to the. By default, Linux sets the basic file permissions or folder permissions. It is same for all the files that are created or all the folders that are created. However, we can modify that by using chmod or chown command. Let's first create users. I will create DevOps engineer user by add user command, also web developer user by using add user command. It's created. Let's switch the users su space hyphen DevOps engineer, and in other tab open su space hyphen web developer. Then let's do cd change directory in the web developer to the tmp folder. Then let's create the file kf.sh. Perform vim kf.sh. Let's do the simple command, that is echo Linux is easy. Escape :wq. Enter. Now the shell script is visible. Now let's switch to DevOps and see that shell script. We can perform cat command, cat kf.sh. We can see that it shows Linux is easy. That means we have permissions to view, that is read. Let's try to see if we can modify the script. As you can see, it is not allowing me to modify the script as this DevOps user doesn't have the permissions to do so. So that was the default permissions that Linux provides. We can also modify the permissions as per our needs. Let's do chmod space o equals nothing space kf.sh in the web developer. Now as you can see in the DevOps user, cat that is read is also not working. That means the permissions of other user is denied. Even read is also denied. After we do ls ltr, we can see in the left hand side there are certain words, that is like d, rwx or rw or r. These are the file permissions or directory permissions. If there is d in the start, that means that it is a directory, and if there is no d in the start, it means it's file. So r stands for read, w stands for write, and x is equals to execute. The rwx, 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 these are in three sections. The first section is for users, second is for groups, third is for other. User is the user that has created it. Groups is in the groups are many members, that means it is the group permission. And for others, it is some user. Now by default, the web developer user that has created the kf.sh script doesn't have the permissions for execute. So when we do /kf.sh, it won't execute that script. To let it execute the script, let's switch to the root and perform chmod u equals rwx read write execute for the user space kf.sh. Now let's try it again. Now it's executable. Now let's change it again to rw, that is read write. Now you can see we can't perform. Another method for performing these permissions is by numbers. Performing chmod u equals rwx, comma g equals rwx, comma o equals rwx space file name or script. Sometimes it is tedious and tiring. So to avoid that, Linux also supports the number system. That is r equals 4, w equals 2, x equals 1. So if we want all the three permissions, that is rwx, it would be 7. 7 for the user, 7 for the group, 7 for the others. So 777 would be all the permissions given to the user, all the permissions given to the group, all the permissions given to the other user. So instead of writing chmod space u equals permissions comma g equals permissions comma o equals permission space the file or script, we can do it simply by chmod space 777 space kf.sh or the file name or script. And if we don't want all the permissions, we can simply do, if we want read write, we can do 666 so it would be r from 4 and w from 2, so it would be 6. To check this, let's switch to the root user and go to the home directory. Change folder permissions to chmod 777. No, that was about chmod. Now let's understand chown. Chown means change in ownership. It means to give entire ownership of the file or the folder to another user. Let's create a file in web developer user. In lsltr, we can see its ownership is web developer. Now to change its ownership from web developer to DevOps, we must go to the root user and change its ownership to DevOps user. Let's perform chown space DevOps engineer or the user name colon DevOps engineer space the file or script name. Now you can see ownership has been changed. Now if a file has read write in the user and read write in the group and only read in the others permissions, and the folder has only read write in the user and only read in the group permissions, and if other users try to access that folder or the file, it wouldn't happen because the permissions of the folder doesn't allow other users, even though the file allows the permissions for others. If the folder doesn't have the permissions to allow, it won't allow. So we can imagine that file is inside the folder. So if the user group or others has permissions to access the folder, then they can try to access the file if they have permission for it to. And if they have permissions for files and if they don't have permissions for folder, they can't enter the file as well as the folder. So in order to access the file, if they have permissions, they must also have the permissions for the folder. So in short, file permissions cannot override the folder permissions. Let's change the TMP folder permissions to 700. That means only the root user That means only the user has permissions for read, write, execute, and groups and others doesn't have that permissions. chmod space 700 space /tmp. Then if we change the file permissions inside the tmp to 777, that is read, write, execute for all users, groups, and others, even though that file has more permissions, we can't access that file as the folder doesn't allow that permissions to access. So the file cannot override the folder permissions. As you can see, you can't enter TMP by DevOps, let alone you entering the file inside it. The topic is process management in Linux. What is process management and commands? So what is a process? A running program or an instance or an application that utilizes CPU or memory, that is known as a process. An application or an instance or a program cannot directly utilize the resources from the hardware. It uses software, that is an operating system, to communicate with the hardware to utilize CPU and the memory. So this process of instance or program or applications utilizing storage memory from the hardware, and we managing it by stopping, starting, killing the process, or prioritizing or deprioritizing the process is known as the process management. One of the responsibilities of operating system is to manage the CPU, manage the memory, manage the file system, and manage the. For example, a hardware, a virtual machine, or a Linux server, if suppose it has one CPU or two CPU storage, if some user or an engineer performs a tedious or a big task, that is to deploy an AI application that has complex calculations, or for example deploy something related to blockchain or cryptography, that requires a lot of storage, a lot of CPU process, but they only opted for one CPU, which was not enough. So to execute that process, the system will try to manage it. If it utilizes 90% or 80% of the storage, then it runs it, and the rest of the process or the programs would need to get utilized with that rest of the 10%. If suppose that application requires more CPU, if it is like reaches 100%, then the Linux server can get hanged. So we would need to kill that process. Also, it is same for the memory. If an application, let's suppose AI or blockchain, that requires a lot of storage, but we only have limited storage, if suppose 50 GB, but it requires 30 GB or more for its essential packages. So if it has less memory our system to run those applications, then it would give us an error in the logs by saying out of memory. To tackle this, we must opt for higher memory or reduce or delete some unnecessary files or applications. The process of prioritizing, killing, starting, stopping of these processes to manage the CPU and memory is known as the process management. PS space AUX. This command is used to list the processes that are running. PS space AUX space pipe space NL. It is to list the processes with line number. We can see the processes that are running with the line number. If it says 25, then there is 25 processes that are running. PS space AUX space WC word count space hyphen L. This is for only seeing the number of processes that are running. It will not show details of the processes. It will only show how many processes are running. It shows like 25, 20. Now PS space AUX space GREP USR. This will show the process with certain keywords. GREP would filter out the keyword that is after it. Now I have used a USR as a keyword to filter. So GREP would filter out from the running processes and only show the process that has USR. And this command will also show you the process of this command running. To avoid that, another command is same as that is PS space AUX space grep USR space. Now addition would be grep space -v grep and will show only the process that has USR, not the grep command we use to check the USR. Now you can use that by replacing USR by any keywords or process that is like Python, Java. Now PS space -ef. This is also the command that shows the running processes. However, it doesn't show CPU and memory utilization, whereas PS space AUX shows us CPU and memory utilization. In the PS aux or in the running processes, user shows the user that has initiated it. If it says root user has initiated that process. PID or process ID is a unique ID that we can use to kill, stop or start the process. It is used to manage the process. CPU and memory shows its utilization. CMD shows the path or the command that was used to run that process or to start that process. Now, one of the key aspects of process management is to kill certain processes that hang the system, certain process that occupies 100% of the CPU that would hang the process. In order to resume the Linux server, is a need to kill that process. In order to kill the process, the command is kill space PID, that is the process ID. It would kill the process. And if the kill command alone doesn't kill, we can forcefully kill the process by kill space -9 space process ID. This would forcefully delete the process. Kill space -stop space PID or process ID. This is to stop the process temporarily. And to resume that process again, kill space -cont space PID to resume that stopped process. That was about killing and stopping. Now, to prioritize or deprioritize a running instance, the command is renice RENICE space -n space number. If it is positive number, that is 10 space -p and space PID. If it is a positive n, it would deprioritize that process. And if the n is negative, it would prioritize that process. It starts from -19 to 20. -19 would be the highest priority, 20 would be the least priority. Now, what are services? Services are the background running process that start from the boot of the server. Services are different from the programs. Programs are like Java, Python, that gets terminated when system gets shut down and we have to perform it again. But services are different. Services are background processes that restart or that boots up after the system restarts or boots. It doesn't require manual creation again and again. So some of these services are Apache and Nginx. These are like web server services. It is independent of us trying to re-enable or restart it again after the shutdown. After the system gets shut down and it gets restarted, the services also get restarted from the boot. So to check the services, the command is systemctl space list hyphen units space hyphen hyphen type is equals to services. This would show you the services that are running. In my case, there is no services that are running. For example, Nginx or Apache. If it is running, it would show these services. To stop these services, the command would be systemctl space stop service name. For example, Nginx, that would stop that services. And to start that service again, command would be systemctl space start service name. For example, Nginx, that would start that service again. The topic is monitoring in Linux. What does monitoring in Linux mean? Monitoring in Linux simply means to check the process information that consumes disk storage. In short, to check the processes that are consuming the CPU memory and disk, to manage the processes and to clear some memory and to have more space for the CPU and its performance optimization. Monitoring simply means to monitor the system, to check if there is certain files, certain tasks that are running that is taking a lot of space, a lot of CPU, a lot of memory, and to manage those by monitoring them. Commands for monitoring are top. This command is used to check the CPU and memory utilized by the process in the real time. We also know that PSOX also shows us this data. However, the information that PS space AUX shows is not real time, whereas top command or that command that is htop shows the real time data that updates real time. And same is for htop. This command is same as top, but it shows that same data with clean UI, and it is better than top to understand CPU and memory utilization, the processes in the real time. vmstat. This command is used for checking the system performance. It is mainly used to check if there is enough memory or not, and if a system is lagging due to memory. This command shows us how much memory is left and how much memory is utilized, so we can delete or add some memory to the system. Free space hyphen m, also free space hyphen h. This command shows us free memory and how much memory that is being used. This command is best for using in scripts or in code, as we can apply grep and certain filters to get the data of the memory. Whereas top command or htop shows us visual or real-time data that is on the visual or the UI side. So to get more static information in the scripts or in the output, we use free space hyphen m and free space hyphen h to get the memory information that can be used in scripts. And proc. This command is used to show the amount of CPUs that are available. In my case, it shows 4 CPUs. df space hyphen h and du space hyphen sh. These both commands are used to show the disk information. It shows the size of the file system, how much memory it is being used, how much memory is available. It shows in the percentage how much memory is being utilized. Mounted on shows the folder exactly where it is present. It is used to show the disk information so we can manage it. Also, we don't use all these commands on itself. We integrate that using Prometheus or Grafana. When integrated, it shows alerts for better monitoring. So the topic is disk management in Linux. We will be doing a practical session on adding disk volume to an instance. What is disk management in Linux? Disk management simply means to add or remove storage. Applications that run on instance always generate logs each second. With time, these logs can pile up and eat up the storage. To avoid filling up the storage and to not have enough storage for logs or for other tasks in an application or programs, we need disk management to add volumes. Also, by adding volume to an instance doesn't mean it directly fits into the instance so it is usable. No. First, we have to mount it to the specific location that needs its storage, or we can create a temporary mnt or mount folder to mount that volume or storage that we add. By default, the volume we add is a block storage, so it cannot be used by application or programs. To fix that, we must be formatting that volume and create it to the ext4 or xps. So the ext4 or xps format is what the applications or programs can use it. I have already created an instance. So by default, this instance has 8 GB of the disk volume, and I am in the terminal connected with my EC2 instance. So the first command in disk management is lsblk. This command is used to list the block storage attached to the instance. Loops are the virtual disk, and XPDA is the actual block volume that is partitioned into the 4 parts. That includes root. We created the volume with 8 GB in an instance. However, the root volume is of 7 GB. Rest of the 1 GB is utilized by boot. Boot partition helps the instance to boot up. Booting means restarting and starting of the instance of the Linux machine. df space -h space slash shows us that the root folder has 7 GB approximately storage, and 1.8 GB has been used, and it's mounted on slash, that is root folder. Boot folder contains EFI or boot files that helps in restart and start of the Linux environment or the instance. Now when we do fdisk, this command shows or gives us more information on the partitions. Fdisk space -l to see more information on the partitions. Now let's create the volume. Go to the EC2 instances, then Elastic Block Store, click on volumes. So by default we have 8 GB volume while we created that instance. Click on create volume. One more thing to remember is in create volume, select the region that is the region same as your EC2 instance. For example, in my case, I have created instance in AP South 1A. So I will be selecting the availability zone in the volumes same, that is AP South 1A. I'll be doing 9 GB storage. Create volume. Wait for a few seconds until it's initialized. Now after it is created, click on actions. In the drop down of instances, select the instance that you have created. I will select the instance that is add volume kev. For the device name, I will select HDF. Attach volume. Now we have successfully attached that volume to the instance. Now let's confirm it by doing lsblk to list the block volumes attached. We can see xvdf that has 9 GB of the disk storage. Now let's create the directory. This directory will help us mount the attached volume. We will be mounting this volume into this folder. Go to the root user by performing sudo space su space hyphen. Now I'm in root folder. I'll perform mkdir space -p space /mnt/caf -volume. So /mnt/caf volume is a temporary folder to attach the volume. Let's do ls/ltr/mnt. Now it shows caf volume folder is created. Now next step is to create the file system. The command is mkfs make file system space -t space ext4 space /dev/xvdf. Xvdf is the volume which we have added. Now it successfully created the file system. Now next step is to mount that /dev/xvdf into our temporary folder or into our folder that we have created, which is /mnt/caf volume. The command is mount space /dev/xvdf space /mnt/caf volume. Done. Let's confirm it with lsblk. Now as you can see, XVDF is the volume 9 GB attached to our instance successfully. It is attached into the folder that is /mnt/caf volume. Let's confirm it by creating a file in this folder. Change directory space /mnt/caf volume. Now we are in the caf volume folder. Let's create a file by doing touch space caf khan ls. As you can see, the file has been created. That means we have successfully created the volume, attached that volume into the instance. df-h also shows that it took 1% of the storage. That means file has been created successfully. In real world scenario, it would be like a folder that is about to get filled or it is running out of storage. So before it runs out of storage, we would be recognizing that folder and performing the same steps we have performed but into that folder, and we would be attaching that volume. The topic is networking in Linux for managing networks or networking concepts using commands. If you haven't watched the networking concepts video, which is a complete playlist and also one short video of compiling of basics concepts of networking, go check that out first. The first command is if config. Full form is interface configuration. So what is interface? Interface is a point of connection between system or device and a network. If config provides information on IP address, MAC address, maximum transmission unit, etc. There is an updated command for if config, that is IP. As you can see, this provides information on IP, MAC and maximum transmission unit trace route. Also, if you try the commands and see like all packages, please perform the packages install and then perform the commands. The trace route command would be trace route space the website you want to check the route for. In my case, I will be doing trace route space google.com. Trace route command is used for troubleshooting and to find the latency or delays between sender and receiver path. There is also another command that is trace path. This is similar to trace route. This also provides information on latency and delays between sender and receiver path. In my case, that is google.com. It is also used for troubleshooting purposes. Next command is ping. This command is used to test the connectivity between the two devices in a network. For example, let's do ping google.com. This shows by default 64 bytes time, that is like 24 milliseconds, how much time it takes to travel, and the time taken to connect and provide information is shown in the time section. And 64 bytes is the data that is sent. TTL stands for total time to leave. It is to prevent the infinite loops. TTL ensures that packets don't circulate forever in the network if a routing loop occurs. So it acts as a safety mechanism, dropping packets that take too many hops to reach the destination. If we do ping space -s space 1452 space google.com, we are pinging google.com -s, that is size of the bytes that we are sending. In my case, we are doing the maximum transmission unit, that is 1452 bytes. So as you can see, we are able to perform this. What if we increase that 1452 plus 1? If we do 1453, as you can see, we are not able to perform it because it is reaching above the maximum transmission unit. MTR. This is a combination of ping and trace route. It shows information in the GUI format. Netstat. This command gives us network statistics information of different interfaces, including open sockets, routing tables, and connection information. SS is also a command which is an advanced version of network statistics or netstat. Dig. It stands for domain info grouper. This is for DNS troubleshooting. NSLOOKUP. This is same as dig but is an older version of dig. We can perform NSLOOKUP space google.com. These both commands are used for DNS troubleshooting. Next command is route. This is to view, add, delete routes. If we do route add space -net 192.168 or 0.3.0 space netmask 255.255 etc. space GW gateway space 192.168 so on, this command would tell the system to send from the first address to the gateway. Route -n shows us routing information. Route add default GW space the address. This sets the default path for all the traffic that doesn't have specific route. Route space del space -host space address space reject. This command would remove previously added route, in this case blocking the access of the specific host mentioned, that is like 192.168 so on. Host, this command shows the domain name for a specific IP address. If I perform 8.8.8.8, which is the domain of Google, it would show us the domain name of the IP address, that is google.com. ARP, this command address resolution protocol to view and add content to kernel's ARP table, that is to find MAC address information. IWconfig, this command is used to configure the wireless network interface to view, to use and serve basic Wi-Fi details, SSID and encryption. Hostname, this is to view the host name of the system. In my case, this is desktop pqter. The commands are curl and wget. Curl is majorly used to call the APIs. If we perform curl get and the link, we would be able to download the API with the link. For example, if we perform curl space -x space get space the link of the API, we can see the information, the API. Now wget. This command is also used to get or download information from the internet by providing the link. If you perform the command wget space the download link, for example, I would be using the file or the document to download. Let's first and switch to the download directory. Perform this command. As you can see, it is downloading, and ls to show it is downloaded. Wget and curl are commands used to download or API or files or documents using the CLI. Who is? This command is used to show domain information. For example, if we do who is space google.com, this will provide all the information related to google.com. Also, we can see information on instagram.com. As you can see, it shows Facebook or FB that is managed by it. If plug status, this is to check the status of the cables plugged into network interface. If top, this command is used to monitor the traffic real time. TCP dump, this command captures the traffic passing through the network interface and it displays it. The topic is Shebang in Linux. What does Shebang mean and purpose of using Shebang in Linux? Shebang is a initial statement consisting of special characters which tells the operating system which interpreter should be used to execute. So it consists of hashtag exclamation path, that is /bin/bash. The hashtag and exclamation says to the system, don't read this text as regular text, look at what is next to it. For example, after hashtag exclamation Shebang, it consists of the path. Most probably that would be /bin. /bin means the binaries /bash or sh or dash. So if we were not to use Shebang, Linux system wouldn't able to know which translator, that means which interpreter to use for executing that shell or that command. Let's understand this by an example. I'll switch to the downloads folder from the root and create a file, that is shebang.sh, by doing vim space shebang.sh. Now click insert after you get inside the file, then perform hashtag exclamation mark /bin/bash. That says to the Linux system we are interpreting bin bash. That would simply mean, Linux interpreter, please use bin bash, that is bash, to translate or to interpret the command by using bash. Also, one more thing, bash, dash, sh, all are same on the core. 90% of these are same. However, most simple or most used is the bash. So we must at least know one. Now, in my case, I will be doing bash. You can also learn bash, which is a standard or which is most common. I'll do echo space Shebang means calling or letting system know which language your command or which language to interpret your command or script to be. Escape WQ exclamation to exit the Vim mode. Now that we have created the file or the script, let's run it. To run it, the command is dot slash and the script name. For example, in my case, that is shebang.sh. It shows permission denied. By default, permissions for execution are denied for users, groups, and others. In my case, I am the user. It still doesn't have the permission by default to execute. To bypass this, we must be performing chmod to let the user have the permissions. For example, I would be doing chmod space 700 space file name or script name, that is shebang.sh. Here 700 means 7, that means all the permissions for read, write, execute. 00 means no permissions for groups and no permissions for others. So only user, that is me, that is executing right now, has the permissions to read, write and execute. Now after we change the permission, let's try it again. Now it's executable. The topic is shell scripting in Linux. We will be creating two shell scripts. One is for files, directories, and another one would be for basic system information. First, let's understand why do we need shell scripting. Executing more than one commands at the same time is known as scripting. So scripting is simply to automate the process. Instead of performing multiple commands simultaneously one by one, we can put them inside a script and just execute that script, so we don't have to perform all the commands one by one. Let's just dive into creating our first script. For our first script, we would be creating a directory and we would be switching into that directory, and when we switch into that directory, we would be creating a file inside it. So let's first perform vim space first script.sh. You can name it anything. Now we are inside the vim or vim editor. So the first important step is to perform the shebang, that is hashtag exclamation mark followed by the path, that is /bin/bash. This would tell the Linux kernel that we are using bash as an interpreter. Perform this shell script. The commands, that is mkdir, kf khan. We also perform hashtag. So anything we put inside an hashtag doesn't get executed or doesn't perform as a command. It is just for the reference. So next would be hashtag change directory followed by cd space kf khan to switch into that directory. Then hashtag create a file inside that directory followed by touch file inside kf-khan-dir. The purpose of this script is to create a directory, then switch into that directory and create a file inside that directory. So let's just save it by doing escape:/wq exclamation. This would save and quit that vim editor and the script. Now that we have created our first shell script, let's just give it permissions for execution. By default, Linux doesn't provide us permissions to execute. Even users that create the file doesn't have the permissions. So first we would need to allow permissions to execute the script. chmod space 700 space script name, that is first script.sh. Now here 7 means all the permissions read, write, execute for the user, that is me performing this script. So 00 means groups doesn't have the permissions for read, write, execute, and others doesn't have the permissions for read, write, execute. Only the user, that is me, has the permissions. 7 means read, write, execute. Now that we have given permissions, let's try to execute it again. Now it's executed. Let's try to perform ls to see the directory is present. Kf directory is created. Let's switch into that directory by performing cd. series space kfn. Now we are inside the kfn directory. That means kfn directory has been created by using that script. Now let's try to perform ls inside that directory to see if the file has been created or not. The file also has been created, that is file inside kfn dir, which simply means our script has been executed. That was to create a directory, switch into it, create a file inside it. That was our first script. Now for the second script, we would be doing basic system information. Our aim for the second script is to know the host name, perform the nproc command to know the number of processing units available, system resource usage by htop, virtual memory statistics, that is vmstat. So we would be putting all these commands inside one script for basic system information. First perform vim space systeminfo.sh. Now that we are inside the vim editor, first insert, then the shebang hashtag exclamation slash bin slash bash. Now one more thing to remember is when we perform scripts, best practice is to provide information about who is creating it, the date when it is created, what is the purpose of this script, and the version of it. Comment out or hashtags so it doesn't get executed, followed by hashtag creator, that is kf, followed by hashtag date, that is 4th February 2026, followed by system info script, which is the purpose of it, followed by hashtag version, that is version 1. So this would be the commented out. It would not get executed. It is just for our understanding of the script. It is a best practice to provide metadata or the information of who creates, when it is created, purpose of it, and what is the version of the script. Now comes the actual part of our script. So first would be debug mode, which is set space -x. When we have multiple commands, or if the script is too long, it would not be efficient for us to perform echo command for each command inside the script, and there also exists a higher chance of us making mistakes while adding the echo statements. We can mislead information. So to avoid that, we can simply put set space -x in the start. That would mean debug mode, which would provide the command information before the output, which means like if we are performing host name, it would give the command that is host name followed by the execution or the output. It would do host name followed by the output. So it would do all of this for each command. So this would avoid us for putting each information or each echo statements. For example, for the htop command, if we do htop, it would be showing htop and the real-time information of the htop command. If it is vmstat, it would be showing vmstat followed by the output of vmstat. So now the next command is host name. This would provide us the information of the host name or the desktop. Now nproc. This command is for showing number of processing units available. htop. This command is for system resource usage. And the last command is virtual memory statistics, that is vmstat. So now that we have added all these commands, let's just save and quit by doing escape :wq exclamation mark. Now let's just try to see if we can execute the script even if we don't have permissions. So as you can see, like we don't have permissions to execute the script by default, even if we are the person that has created it. That means a user. So to tackle this, we would need to give it permissions by performing chmod space 700 space the script name, that is systeminfo.sh. So this would give permissions for read, write, execute for the user, that is me, and no permissions for groups and no permissions for others. No read, write, execute for groups and others. Only permissions for me, the user. That is 7. Read, write, execute. Now that we have permissions, let's try to execute it again. Now it is executable. The UI you are seeing is of the htop command, which means we have successfully executed the script. Htop is a command that shows real-time information, so we can just exit the htop command by performing F10. Now you can see the information of the commands we have put inside the script, that is like host name followed by desktop executor, which is my host name, and nproc followed by 4, that is the number of processing units available. Htop was visible in the real time, which we have exited. We can see virtual memory statistics, that is vmstat. So now you are seeing the information that is like host name, nproc, htop, vmstat. We are seeing this metadata because we have added the set equals -x command, which was debug mode. If we didn't put that command, we would just be getting simple outputs of for each command inside the script, which would be like host name command followed by all this information without any metadata or without any information. So set equals -x command helped us provide information of the command followed by its output. So we could have understand of which command gave us which output. The topic is awk grep in Linux. We will be discussing what does this command do. We already have created a script in our previous video. We will continue to do our commands awk and grep in this. Now that we are inside that script, we know that this script is used for printing basic system information, that is host name, nproc, vmstat, netstat, etc. And in our previous video we have understood the command set equals -x, which means it executes the shell script in the debug mode. So it has the command name, that is host name, etc. above the output of the shell script. However, we also have 2 more set commands inside the script. What does this commands do? First, that is set equals -e, and second, that is set equals -o. We must know that if a script or a shell script has an error, if we don't put set equals -e and set equals -o, the command would eventually get executed and it would show that specific line of code is an error. Rest of the code would be executed or rest of the commands would be executed. However, if we had certain commands or certain script that is used to create or manage files, users, etc., and it has a specific order of steps. The step 1 is an error, the second step and third step would get executed, but we wouldn't get the desired output because step 1 is also required. To avoid these mistakes, we have set equals -e. This is the command that would not execute the code or the script if it has error in it. However, the code or the script would get executed if it has pipe followed by a command that is correct. For example, if I have error in the code or in the script and I followed it by a pipe space echo statement, then that command would get executed even if it has set equals -e. So if it has general error, it would not get executed. However, if it has pipe followed by a command, then it would get executed. Then it would be the same scenario as without using set equals -e. So to avoid that mistake or that anomaly for set equals -e, we use both of this command, that is set equals -e and set equals -o. Set equals -o would prevent that error happening which was happening in the set equals -e. For example, set equals -e was having an error after the pipe. If we perform set equals -o, this would avoid that mistake that was happening in the set equals -e. Set equals -e would not execute the code if it has error, but if it has a pipe statement followed by a command, it would eventually consider it. However, if we use set equals -o, it would not let that pipe anomaly happen. So that was about set statements. Now let's understand grep and awk. Script was having only these commands without grep or awk, which was netstat, hostname, etc. Let's try to execute it. It shows the output of these commands. However, we must know that awk and grep are the commands in Linux that is used to filter out details. For example, you can remember this simply by this observation. If we are shopping online, we just don't put a product information and just buy. Sometimes we also use the filters like price, size, etc. So this is similar to it. Every output of the shell script has a lot of information to filter out the information which is required at the moment or in a situation that requires only that information. To filter out it, we use grep and awk statements. For example, if we perform grep followed by a word, it would filter out that word and it would give the output that line that has that word in it. Now about awk. Awk is similar to grep. It is also used for filters. However, awk filter outs information in the columns. We have to specify the column in the syntax of the awk and it would filter out the information and print the entire column. For best results, we can use both of these commands. So it filter out certain keyword by grep and followed by the awk. So let's just first do grep netstat space grep space systemd. Our aim is to filter out only the keyword that has systemd. Let's execute. As you can see, grep command filter out netstat output and only gave lines that had systemd in it. Now let's do awk. So we'll use the same grep systemd followed by the awk statement, that is pipe awk space apostrophe flower bracket print $5, that means fifth column, comma space column 6, that is $6, comma $7, which prints column 7, flower bracket close apostrophe. Let's save it by escape :wq exclamation. Let's execute it. As you can see, it has executed both grep and awk command. For grep, it utilized systemd keyword to print only lines that had systemd in it, and we added awk statement, so it has printed 5th, 6th and 7th column of netstat. So in short, it printed systemd filter or keywords that had systemd in it, followed by 5th column, 6th column and 7th column of netstat. We can manipulate it as we wish, and we can remove 6th and 7th, so it only prints 5th. We can change that to 6th to only print 6th in the systemd of the netstat. So that is it for the video today. I hope I made the topic simple and insightful. Thanks so much for watching. Make sure to like, share and subscribe. Have a great day. Bye.